Okay, so number 7, 4, 3, 2, 1, 0. First difference, -1, -1, -1, -1. So this is a n sequence, but it's a -1. So I just put the -1. You can write -1 like -1, but you don't need to write that once, or you can just write -n sequence. And -n sequence starts when it's -1, and then it goes to -2, -3, -4, -5, because it's right. When n equals 1, it's -1. When n equals 2, it's -2, and so forth and so forth. So we know it's an n sequence, but we have to make some adjustments because we need to get 4. So it's a -1 sequence, and how does -1 become a 4? Or how does -2 become a 3? Or how does -3 become a 2? It's going to be plus something, and that's going to be plus 5. Well, let's see if it works. So when n equals 1, it's -1 plus 5, and -1 plus 5 is 4. Check. Let's make sure when this is the first term, second term, third term, fourth, the fifth term. When n equals 5, it should give me a 0. Let's see if that's true. So here's my sequence. When n equals 5, substitute n with 5, so you got -5 plus 5. And you get 0. Is that the fifth term? Yes, it is. So we are correct. Okay. 7, -9, -6, -1, 6, and is that 15? Seems odd. So what is this? 3 plus 3, right? Plus 5 plus 7, and then this is going to be plus 9. Okay, it's not a linear sequence anymore, right? They're not the same. So it's not going up by the same amount. So it's definitely a quadratic. So take the second difference, you get 2, 2, 2. So we know it's a quadratic sequence, and we need to figure out if there's a coefficient here. So the coefficient, we divide 2 by 1, and we get 1, right? We can write it like this, or better yet, let's write it without. Okay, so it's going to be just simply n squared. So an n squared sequence is 1, 4, 9, 16, 25, right? Let's subtract -1 minus 9, -10, -10, -10, 6 minus 16 is -10, 15 minus 25 is -10. Remember, we're subtracting, right? So it's an n square sequence, and since they're all the same, we're not going to do anything else. We're going to stop right there. And how you can tell, how does the 1 become a -9? How does the 4 become a -6? How does the 9 become a -1? So we got to adjust an n sequence, sorry, right? And we're going to write -10. Let's see if that makes sense. So when n equals 1, I have 1 squared minus 10. 1 squared is just 1, and 1 minus 10 equals -9. Check. Let's see the third term should be -1. So the third term, let's substitute n squared minus 10 was 3. We got 3 squared minus 10. 3 squared is 9. Minus 10 equals -1. Check. Check. So this is our sequence. -4, 12, 38, 74, 120. Find the first difference. This is going to be 16. 26, really? 36, 46, let's just check, yeah. So it's definitely not linear, right? They're not the same, not going out by the same amount. So if you take the second difference, now that tells that it's a quadratic sequence, so it's an n square sequence. Let's half the 10, half 10 is 5, so it's a 5n sequence. So n squared, which is 1 times 5 is just 5. 2 squared is 4 times 5 is 20. 3 squared is 9 times 5 is 45. 4 squared is 16. 16 times 5 is 80. 5 squared is 25, and that's going to give me 125. Okay, so let's subtract. Hopefully I did it correctly. So negative 4 minus 5 is negative 9. Negative 12. Sorry, 12 minus 20 is negative 8. Yeah. 38 minus 45 is negative 7. 74 is obviously negative 6. Negative 5. Right? So because they're all different, I have to. So I know it's 5n squared for sure. Now it's going to be n. What sequence is this? This is a plus 1, plus 1, plus 1, right? Plus 1. So it's definitely an n just n sequence, right? And an n sequence goes 1, 2, 3, 4, 5. When n equals 1, equals 1. When n equals 2, the second term is 2. When n equals 3, the third term is 3, and so forth. So now it's 5n squared plus n, but we have to make an adjustment because we want to get negative 9. So we don't truly want the 1. We go on negative 9. So how does the 1 become negative 9? Minus 10. 2 minus 10 is negative 8. 3 minus 10 is negative 7. 4 minus 10 is negative 6. 5 minus 10 is negative 5. That seems to do the trick. Double check. Pick 2. So let's pick the first one. So when n equals 1, it should give us negative 4. Let's see if that's true. 5 times 1 squared plus 1 minus 10. 5 times 1 squared is 5. Plus 1 minus 10. 5 plus 1 is 6. Minus 10 is negative 4. Check. So our first term. Let's check the fifth term. 1, 2, 3, 4, 5. When n equals 5, our fifth terms should be 120. So it's 5 times 5 squared plus 5 minus 10. 5 squared is 25. 25 times 5 is 125 plus 10 plus 5. Sorry. Plus 5 minus 10. 125 plus 5 is 130 minus 10. 120. Check and check. Okay. So that's one part of your homework. Let's see what else is available. There's some graphing to do. Oh yeah, this one. So I was told that I didn't do number 3, so I'll do number 3 now, and I'll do 4 and 4, 5, 6. So 3 was from yesterday. Okay, so let's start. Y less than 3, so let's find 3. It's here. Right, so it's going to be a straight dashed line. It's a horizontal dashed line. So that is going to be my y less than 3. And the other one is going to be, it's 1. My slope is negative 1, so it's 1 over 1. And let me change colors. My y-intercept is positive 1. So over here. So it's a line that goes down. So it's 1 down, 1 to the right. 1 down, 1 to the right, 1 down, 1 to the right, blah, 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 blah. Same thing. Oop, I forgot to do the test point. Shoot. Okay, so it was here. Let me pick 0, 0. So can I, y less than 3, let me pick 0, 0. But the only number I'm going to substitute is the y value, which is 0. So it's 0 less than 3. Yes, it is. So we know that we want this. Okay. And you know what? I'm going to make it just a little bit tinier because I'm going to make it just like this. Right? And then I'll do the rest. Blue. Not blue. 1 right here. And this is a negative, so it's going to be down 1, 1 to the right, down 1, 1 to the right. So this is definitely a straight line. Label it y less or equal to negative x plus 1. 0, 0. I can do 0, 0 here. So if I do 0, 0, if I do my test point, y is less than negative x plus 1. 0 less than 1. Is 0 less than 1? Yes. So that means we want the side where the 0, 0 is, which is under the line. So it's going this way. Okay, so our point of intersection Hang on a second. 1, 2, 3, 4. A point intersection is going to be, let me draw this like that for you guys. Now I can extend, and I'm going to shade in with the red. Okay. And this is our solution. And then on a test, obviously I would ask you to pick a number in this area, and then what do you call it? Plug it in both inequalities and see that's true. So for the first problem here, I'm going to do it the other way, just in case you don't like shading. So let me graph the first one. The intercept is -3. It's a positive slope, right? There's a 1 in front of the x, so it's just 1 up, 1 right. 1 up, 1 right, 1 up, 1 right, 1 up, 1 right. And it's a straight line. Let me label that. Y is greater or equal to x minus 3. And let me do a 0, 0 here. So if I put 0 here and 0 here, I'm going to get the 0 is greater than -3, and that is definitely true. So this is going to be, I'm shading everything on that side. Okay. Blue, it's a negative slope, and it starts at -1. And actually, I said I wasn't going to do this. And -1 and 1, so it's one that goes 1 down, 1 left. So again, it's this. It's a straight line. So if I label these parts in this manner, I have, this is section 1, section 2, section 3, section 4, right? So one of these 4 sections is the area where it would overlap, where those two, you know, if you were to shade, would overlap. So because I don't want to make that mess, I'm going to do it separately. So I'm going to take a point here in section 1, obviously 0, 0, and I'm going to see if it works. So if I take 0, 0 and put it over here, I get that 0 is greater than -3, and that's true, so that works. And then if I put 0, 0 over here, I get that 0 is greater than -1. All right, look at that. On my first try, I found out that 0, 0 is here, so this whole area here would be my solution area. And just to double check, okay, and just to prove it to you guys, I'm going to do all 4 sections. So let me do section 2. In section 2, I'm going to pick the value, this point right here, 5, 0. And so the point is 5, 0. The x is 5, the y is 0. So I'm going to put 0 and 5 and see if it's true. So 0 is greater, 5 minus 3 is 2. So 0 is not greater than 2. So I know section 2 already is not working. I don't even have to do the second one, because if it didn't work for one inequality, it doesn't matter. It has to work for both of them. So section 2 doesn't work. Section 3, let me pick this point right here, which is 0, -5. It's 0 and -5 on the y-axis. So let me put it over here. -5 is greater than 0 minus 3. -5 is 0 than -3. That is not true, right? So section 3 already, I don't even have to do the rest. It's already a bust. Section 4, let me pick -5 and 0 this time. -5 and 0. -5 and 0. -5 on the x-axis and 0 on the y-axis, and substitute. So if I put 0 over here for y value, and then I get -5 minus -3, is 0 greater than the sum of -5 and -3? Yes, it is. So it does work for that equation. Let's work for the second one. Again, 0 is my y value, so 0 is greater than -5, and I'll put that in parentheses, -1. 0 is greater than negative, and a negative and a negative is 5, +5 minus 1. And you're going to see that 0 is not greater than 5 minus 1 is 4, so it's not true. It worked from one inequality, but it didn't work for the second one. So points in here, in section 4, works for one, works for the other one. So the only one that worked, the only point that worked for both inequalities was a point in this section. So your solution is this section right here. That's your big S, your solution. Oh, look, a heart. Okay, so that's your solution. Any point in this section will make either inequality true. Okay, so it's a little bit more work, but it might be a little neater. Okay, so just in case, and no, you don't have to do it that way. That's seaweed, by the way. X less than -3, so we're going to look for on the x-axis for -3. It's a straight line, what do you call it, vertical line, solid. So for here, let's put 0, 0. So 0, if the point 0, 0 is the x value, y value, so I'm going to substitute 0 over here. That's it. Is 0 less than -3? No, it's not. So we don't want this side because the test point did not work. So we want to, this is what I'm interested in. Okay, the points on this side will make that inequality true. Okay, the second one, oh gee, I have to change this. So let me just change it over here. 5x plus 3y is greater than -9. So it's going to be 3y greater or less than -5x minus 9. Remember, this 5x, we're going to throw it that way. And if you throw it to the other side, it needs to change the sign, right? So that's a little trick. Yes, you can do -5x on this side. It's all the same thing. Okay, so we're throwing the 5x on the other side, but when I throw it to the other side, it becomes negative. Now I have to divide this by 3, divide this by 3, divide this by 3, divide this by 3. I'm going to get that y, because it's greater or equal to -5x over 3, minus 9 divided by 3 is 9. So that's my equation, right, in slope-intercept form, which I can now use it to graph. My y-intercept is -3. It's a negative slope, so it's something that's becoming down. So it's -5. It's -5 down, 3 to the right. 1, 2, 3, 4, 5, and 3 to the right would be somewhere around here. 1, 2, 3, 4, 5. 1, 2, 3. Okay, just continue. And it's also a straight line. Okay. Now we either want to pick above this red line or under this red line. So that's the choice that you have to make. And to do that, we take the test point and we use 0, 0. So you can take this fraction rate, this inequality, which is the same thing as the first one, except it's written in a different way. Well, let's take the point 0, 0, see if it works. Y is 0, greater than -5 over 3 times 0 is just 0, so I'm not even going to write that, so -3. Is that true? Is 0 greater than -3? It is. So with red, I'm going to shade. With red, I'm going to shade. So look. Shade this. So we want everything above the line, and the only part that they intersect, and let me just extend my y-axis a little bit. So you notice that the red and the black would overlap here. So this is your solution area. Any point on that section would make both inequalities true. Okay? It's not that difficult. Okay, guys. Again, we got to switch both equations, so let's take care of the first one. So it's -3y. I'm going to throw the 4x to the other side, but when I throw it to the other side, it becomes -4x plus the 9 that's already there. Now I have to divide everything by -3. And if I do that, two things happen. My y gets isolated. My sign flips the other way. A negative and a negative is a positive. I can just write this as 4/3 x. A positive and a negative is a negative, and 9 divided by 3 is 3. So that's my equation, the first line. Let me graph this. So my y-intercept is this. It's positive, so it's going to go 4 up, 3 right. 1, 2, 3, 4, 3 right. 1, 2, 3, 4, 3 right. Okay, 1, 2, 3, 4, 3 right. And I'm sort of gauging for the ones that are outside. So this one is a dashed line. And I keep forgetting to label this. I would have definitely lost a point in the regions. And then now let me do this second line. We got x plus 3y greater than 6. So 3y minus x on each side. So I'm throwing the x on the other side, minus x plus 6 it becomes. Now I have to divide by 3. Divide by 3. Divide by 3. My y gets isolated. And y is greater than negative x over 3. If you like to write a 1 over there, you can. Plus 2. So this is a negative slope. The intercept is 2. So it's down 1 and 3 to the right, down 1, 3 to the right, down 1, 3 to the right. Okay. And it's a dashed line. Oh, I didn't do any tests. Ugh. It's Friday, forgive me. 3x plus 2. So let me go back to the, let me just take care of the blue. So for the blue, let's do a 0, 0 test. Okay, so for the blue, 0, 0 test, so either going to be above the blue line or below the blue lines. So if I do 0, 0, y equals 0, x is 0, so that's going to be just 0 plus 2. Is 0 greater than 2? No, it's not. So for the blue line, we want above the blue line. Okay, let me go back to the red. So for the red, if I do a 0, 0 test, right, substitute the point 0, 0 in for x and y, I'm going to get that 0 is greater than negative 3 because 4/3 times 0 is just 0, so that cancels out. So 0 is greater than negative 3. And for the red line, I want the side, so it's above or below the red line. It's above because 0, 0 is above that. So for the red line, I want the area that is above this is what I want. Now, where the red and the blue intersect is your solution area. Right here. Okay, and again, you please, and I know we're not doing it right now, but I want you to take a point from here, pick an ismy point, and just to prove it to yourself, substitute that point to both inequalities, and you will see that they both work. Okay. I'm out of seaweed. Okay. And this next one is, I believe, 5 and 6 on the absolute value. So let me write this down. 5, 9 greater, no, that's not it. Uh-oh. What? Well, let me do 11 and 12. So we need to come up with the equation of a line that passes through 0 and negative 3 and negative 5 and negative 5. x1, y1, x2, y2. So it doesn't matter which one. Remember that it's change in y over change in x. So y2, which is negative 5, minus y1, which is negative 3. x2, which is negative 5, minus 0. Negative 5 minus negative 3, it's negative 5 plus 3, so that becomes negative 2 over negative 5. And this is just going to be 2/5. So that's my slope. Let's use our equation, mx plus b. So if I do that now, I can fill in, I need to find this guy. I already found m, right? So I need to find my intercept. So let me replace the m with 2/5. I still have a y, an x, and a b, 3 variables, of which 2 more I can get rid of. And I'm going to use the point 0, negative 3. So I'm going to use the point 0, negative 3. So my x value is 0, so this is going to be 0 times 0. My y value is negative 3. And then plus b. Now I can solve this little equation. Negative 3, this becomes 0, and this b. So my intercept is b, is negative 3. So now I have my slope, my y-intercept, and I can finally write my equation, which is y equals 2/5 x minus 3, where this is my intercept and this is my slope. It's my battery all the time. 12, which means I have to get my charger, which I hopefully did not leave at school. Uh-oh, I did. And now we have to do the other side. Okay, so quickly. 0 and 5. It's 11 and 12, is that it? Shoot. 11, 12. 0 and 5. 4 and negative 4. So by now it should be pretty obvious. So again, x1, y1, x2, y2. So our slope is y2, which is negative 4, minus 5, which is y1. x2, which is 4, minus 0. Negative 4 minus 5 is negative 9, and 4 minus 0 is 4. So that's our slope. Y equals mx plus b. I need to find this value, right? I already found m. So in order to find b, I can use one of these points. I can use actually any point on the line, but since we don't have the line, these are the only 2 points I know so far. So let's use the one that has a 0. So the m is negative 9 over 4. I can use that. X is 0, thank you. And then my y value, which is this guy, is 5. So now I can solve this equation because I got rid of 3 of my variables. 5 equals negative 9 over 4 times 0 is just 0, so this guy's go out. And b equals 5. So I have my slope, I have my y-intercept. I can write my equation. Y equals negative 9 fourth x plus 5, and that's the equation of the line. And if you were to draw that line, intercept is 5 somewhere over here, it's negative. So what I can tell you is that this point 0, 5 is there, right, which is right here. 4, negative 4 is also there somewhere. Hopefully I did this a little crooked. 4, negative 4, 4 up, down 4. Oh, 0, negative 5 should be here, sorry. Just trying to show you where those 2 points. But there are many other points on this line that would make that equation true. Then the inequalities, I can't find them. The absolute value. Oh, lucky you, just found it. Don't celebrate. And we're doing number 5 and 6. Okay. X minus 2 minus 5 is less than negative 2. Really? Okay, so let's do this. The first one, we want to isolate our, what do you call, the absolute value. So we do plus 5, and this goes out, and I have absolute value of x minus 2 is less than 3. This is an AND problem, right? So an AND problem is going to look something like this, right? Where this x minus 2 I'm going to put in here, and that 3 goes in here, and guess what number is going to be here? Negative 3. So if you want to go straight to that and you memorize this, you can. I like to draw my number line. I will draw it because I still believe that maybe one of you will actually do that to understand why it's in between here. So the absolute value of something is less than 3 when is obviously the absolute value 2.9, 2.8, 2, 1, 0. The absolute value, all these numbers, not 3, are less than 3. Negative 1 is also less than 3. Negative 2 is also less than 3. But when I get to negative 3, no. But anything up to negative 3. So this is why I set my problem like that. The absolute value of whatever I'm taking, okay, to be less than 3 are values between negative 3 and 3. And that's how I set it up. Plus 2, right? We're going to do plus 2 on everybody. This one's simple enough. This goes out, x in the middle, 3 plus 2 is 5, and negative 3 plus 2 is negative 1. So the x value, if I were to graph it, is going to be anything between negative 1 and 5, not inclusive. Right, so if I were to pick a value so I can plug it in here, substitute, as long as it's between negative 1 and 5, it will actually give me something that is less than 3. So let me pick a number. What's something between negative 1 and 5? 0. If I pick 0, 0 minus 2 is negative 2. The absolute value of negative 2 is just 2, and 2 is less than 3. Let me pick the absolute value of 4. 4 minus 2 is 2. Absolute value of 2 again is 2, and 2 is less than 3. So any number between these two makes this guy true. Last one. Don't you cry. 5 and 6. Okay, so 6. Oh, all the easy ones. N plus 2 greater than 5. Let's isolate minus 2, and we get that the absolute value of n is greater than 5. When is the absolute value of anything greater than 5? So this is an OR. Okay. So when is the absolute value of something greater than 5? Well, the absolute value is greater than 5 when, if I were to draw a number line, so again, if you didn't want to draw a number line, you are going to do this straight away. So this has to be greater or equal to 5, or has to be less or equal to negative 5. That's your little trick. So you're going to set this to be greater or equal to 5, or less or equal to negative 5. But to understand that, I like to draw a number line. So when is the absolute value of something greater than 5? Well, greater or equal to 5. So if it's 5, it works. If it's 6, it works. 7. And all these numbers to the right of 5 make this true. 4 doesn't work. 3, 2, 1, negative 1, blah, 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 blah. Negative 5 works. Absolute value of negative 5 is 5, and that's definitely greater or equal to 5. Negative 6 works. Negative 7, negative 8. So numbers to the left of negative 5 works. The only numbers that don't work is this in between here, this empty space here. They don't work. If I take the absolute value of 3, it's 3, which is not greater or equal to 5. So it don't work. So I want to set this. So when I set it, notice that I'm setting two separate inequalities. One has to be where the values are greater than 5, and the other one greater or equal to 5, and the other ones are values that are less or equal to 5. And these are set. I'm pretty much done. Okay, so yeah, that's it. And I think we're done.